I'm going to show you everything you need to know for the photosynthesis required practical, and it's one of those things that comes up a lot in the exams. And I'm going to start with the easiest things that examiners would expect, and I'm going to move up to the hardest things that you need to know to get the top marks. First of all, the easiest thing to know is what equipment we are going to use. So you start off with a meter rule, and then you will need a lamp, and it has to be an LED lamp. And then you take a boiling tube and you place it 10 centimeters away from the lamp, and then you have to fill the boiling tube with sodium hydrogen carbonate, and then you place pondweed into the boiling tube with a cut end at the top, and then you leave it for 5 minutes. After 5 minutes, you should see bubbles starting to appear from the cut end, and you then take a stop clock and you start the stopwatch and count the number of bubbles produced in 1 minute. So that is how to set it up. Now moving on to the next hardest level is why the experiment is set up in this way. So a common question is, why do we use pondweed? Well, pondweed is already an aquatic plant and it's used to living in water, so it's going to be in a solution of sodium hydrogen carbonate. And as photosynthesis happens, it's going to start give off bubbles of oxygen. Now, if it wasn't in the water, you would not be able to count the bubbles of oxygen because you would not see them. The second most common question is, why do we add sodium hydrogen carbonate into that boiling tube with the pondweed in it? And the sodium hydrogen carbonate provides the pondweed with carbon dioxide, which is one of the ingredients or reactants that is needed for photosynthesis. And the third most common question is, why do we use an LED lamp? So LED lamps, they are more efficient and they give out less heat. Now, if you use a normal lamp, normal lamps get really hot, and if you've got a boiling tube which is about 10 centimeters away from that lamp, it's actually going to heat up the water in that boiling tube, and temperature is one of the factors that can change the rate of photosynthesis. So you don't want that to happen. Okay, moving on to the next level now is what we observe and how we measure it. So you're going to see the bubbles of oxygen, and then you count how many bubbles of oxygen are made in 1 minute. So you repeat the experiment, but you do it at 20, 30, 40 and 50 centimeters away. So I'm going to talk next about variables because you need to understand what the variables are. So there are 3 types of variables. So the first type of variable is called the independent variable. The independent variable is the light intensity because that is what we are changing. So what do you change every time? That's the independent variable. Now, the dependent variable. So the dependent variable is what changes. So the independent variable was the distance, because we go 20, 30, 40, 50. And when we change the distance, what do you see happening? Because you did that, you see the number of bubbles is changing. So the dependent variable is actually what you measure, what results you write down, and that is the number of bubbles. And then the control variables. Now the control variables definitely is what we're going to be keeping the same. So we always keep the same concentration of sodium hydroxide inside that boiling tube. So it's the concentration of sodium hydroxide is number 1. The second type is we always keep the same type of plant. It has to be pondweed, and it has to be the same length of pondweed as well. And also we keep the volume of water the same in here as well, and we always keep the same lamp. Okay, you can't be changing lamps because different lamps might have different voltages. And finally, the hardest part, which is the errors and the improvements. So the first thing I would say is, the most obvious one is counting bubbles, because that can be inaccurate, and it could be because you might miss a bubble. The rate of bubbles might go fast or slow, and you might miscount. And also the bubbles might be different sizes. So you might have a big bubble and then followed by a small bubble, and they have different volumes. The second thing could be the effect of the lamp. So even though you are using an LED lamp and they are very efficient, they don't give out much heat, it may still increase the temperature of the liquid in there. And another source of error could be that even though you try your best and you make sure that the pondweed is 10 centimeters long, it may not be exactly the same length each time. And it could be that different parts of a plant, even though it's all pondweed, the leaves may be different sizes as well, slightly different sizes, and that can affect your results as well. And then how do you improve it? I'm going to show you another experiment to show you how to improve it. So this is a more accurate way of improving the experiment. But this time we have the pondweed in a beaker of water and you put an inverted test tube in there. And what you're collecting now is not the bubbles. You're not actually counting. You're going to still use the timer for 1 minute, but you are going to count the volume of gas that you collect in there. To make it even more accurate, this could be replaced with a measuring cylinder. And then I've seen this one as well. This is from an exam question. So this experiment is exactly the same setup. Well, not exactly, but what they've added here is a thermometer so that you know exactly what the temperature is. That would make it more accurate. They've also put the boiling tube in a water bath. And what the water bath does, it actually stabilizes the temperature. So it stops the water in the test tube from getting too hot too quickly. So it helps to keep the temperature constant. And another thing that you could use is a light meter. So that will give you really high marks. If you say that different lamps might give different amounts or intensities of light. It also depends on the time of day that you do the experiment. You can also say that you could use a light meter to measure the exact intensity of light.